No, wait a minute, wait.
Oh,
I'm going to draw it.
which question is this?
Why does marginal cost intersect average variable cost and average total cost at their minimum points? I'm going to draw it, and please make sure that you're not telling us that it intersects them at their minimum points. Please explain why it intersects them at their minimum points.
Okay, I'm going to wait until you draw it because the visual helps me.
Problems?
Cole is really good.
You okay?
I didn't do anything.
Clearly it's good that you guys don't sit near each other during class. All right.
Okay.
Go.
So, marginal cost is the cost of making one more. And if the cost of an additional unit is less than the average, then the average will fall. If the cost of an additional unit is greater than the average, then the average will rise. The point where ATC and ABC meets MC is where it goes from decreasing to increasing.
Where it goes from decreasing to increasing. What
Where,
does?
where ATC and AVC go from decreasing to increasing.
Right.
When
These are all good explanations as to that. He does.
When MC and ATC meet and when MC and ABC meet, the cost of making one additional unit is the same as the average.
Now, that's a good look. You know, I never think about saying that.
You made us say it one time.
At this point, that's where MC and ABC are the same. This is where MC and ATC are the same, right? So effectively what we're saying is that right here, the cost of an additional one is the same as the average, correct? And here, the cost of an additional one is the same as the average, right?
Yeah.
So then, anywhere that marginal cost lies below either average variable or average total, then the cost of an additional unit is lower than average variable or lower than average total. And so, if the cost of an additional unit is lower than the average cost, well then the average cost has to decrease. Okay, it's a mathematical thing. All right?
So is that short run economies of scale?
No. That's increasing returns. Increasing marginal returns.
Okay.
Okay?
It's
So that
yeah,
point,
when it's
and then
going
it's
down, it's
decreasing.
really increasing, but then when it's going back up, it's decreasing.
Well, I'll get back to that in a second. I'll help you out with that in a minute. All right. So now, this is diminishing marginal returns because
It's going up.
our costs are rising. By making an additional unit, our costs begin to increase. And AVC, our average variable cost, rises because the cost of an additional unit is greater than the average. Again, that's a mathematical thing. Okay? The real question here, though, is this. We understand that it's marginal cost that helps these have their shape, right? So then let's get back to the real ultimate final point. What is it that gives marginal cost its shape? Diminishing marginal returns. Now, from here to here, and really, there we go. We'll do that because theoretically these are the same at one unit, right? Okay. So from here to here, increasing marginal returns, yes? But then from here on, diminishing marginal returns, yes? Now, so that explains the shape of that, which explains the shape of these. Why? Why is this true? Why is the marginal cost curve shaped that way? Why do we at first experience increasing returns? Increasing marginal returns?
Because the cost of going from 1 to 2 is so great, and then every time that you add another one, you don't have such a differentiation in cost.
Yeah, I like that. The idea is the cost of going from 0 to 1, okay, is great, and the cost of going from 1 to 2 is probably still pretty high, although the second one is probably a lot cheaper than the first, right? In fact, what's the cost of making a second unit of anything compared to the cost of making the first one? It's got to be a lot lower, doesn't it? Okay, it's got to be a lot lower. Because in order to make that first one, all your setup, all your planning, every expense up to that point of production goes into that first unit. The second unit, parts and labor. That's it. Okay? So the second unit, obviously, way less expensive as a unit. Okay? Why doesn't that continue? why doesn't that greater productivity, why doesn't that greater return per input continue? Why can't we continue to make our business more efficient as we add units of input? So what? Which resources are limited that really put a bind on us? That's a what kind of input? Fixed input, right?
Yeah.
So our fixed inputs have some limits. And because our fixed inputs have some limits, we can only add so many variable inputs until we get too many people in too small a space, right? Okay? So the big picture here is this. Big giant warehouse. Nobody in there working. Add an employee. Much more efficient. Add a second employee. Wow. Now these guys can divide the labor and specialize a little bit. Okay? But when you get up to like 35 or 40 employees, all of a sudden it becomes, yeah, we're sort of running low on space here. These guys can only be so much more efficient beyond a certain point. Okay? And then you got people waiting around to use like the forklift, or waiting around to use, to move pallets or something like that, or to use the one computer that helps do inventory. Okay? So I've used the phrase before, you can't feed the world out of a flower pot. That's why that's shaped like that. We can become more efficient as we produce a second tomato, but growing 1 million tomatoes out of a flower pot, never going to happen.
So if we write the reason it's shaped like that is because you can't feed the world out of a flower pot?
No, you can't do that. And that's the tough thing about this. I'm not going to accept any of those like buzzwords, catchphrases, analogies, metaphors.
What will you accept?
Wait, so was my answer right?
Your answer's great.
Okay.
Okay. What I'm going to accept is, I'm going to return to the boat fund. What I'm going to accept is something that tells me that you understand increasing marginal returns and diminishing marginal returns. Okay?
So like when I said because the price of adding one more, like the first.
At first is lower, and then later is greater. Lovely.
But
That doesn't still mean
doesn't
why
answer
they
the question.
intersect at its lowest point.
Yes, it does. Yes, it does. So we built it from the top down first. We'll do it from the bottom up this time. Our marginal cost curve looks like this, yes?
Yes.
Right? And it's because of increasing marginal returns and diminishing marginal returns, right? Because you can't feed the world out of a flower pot. You can make a flower pot more efficient up to a point, and then the flower pot becomes less efficient. Yes?
Yes.
Okay? So then, if the cost of an additional unit, and the cost of an additional unit is always what kinds of costs? Variable costs. Because the fixed cost you're going to pay no matter how many units you make, right? So if the cost of an additional unit is lower than the average variable cost, then the average variable cost will fall. So as we experience increasing returns, our average variable cost curve will fall, right? But look at this. Right through here, that little section. Our marginal cost curve is rising, but our average variable cost curve continues to fall. Why?
It's below it.
Yes, because the cost of an additional one is still lower than the average. Though it's rising, the marginal cost, it's still lower than the average.
The decline of that slows, though, doesn't it? Because it's
And thus its slope starts to flatten. And then we hit this point where its slope is 0. And then the slope becomes positive.
When diminishing marginal returns
When-
increases, then average variable costs.
When our marginal cost exceeds our average variable cost. Yes?
Wait,
Awesome.
So when they
So the same thing applies to average total cost, because all we've done with average total cost is add what on top of average variable? Average fixed. Okay? The only difference between this one and this one? Average fixed cost. And we know what average fixed cost does. Okay? Good? The average fixed cost for 1 unit is fixed cost divided by 1. The average fixed cost for 2 units is fixed cost divided by 2.
So if we just wrote, if the cost of an additional unit is greater than the average variable cost, and because of diminishing marginal returns, average variable costs will decrease.
Oh, you did it backwards.
Average variable costs will
Increase. Greater than, right?
increase because of diminishing marginal returns.
The question is, do you know what that means? Or have you just memorized the words?
Well, no, I wrote it from what I thought.
Okay. The key, folks, is always about do you understand what it means? It's nice if you've got the words. I mean, honestly, on some level, that's almost the first step. If you can just memorize the words, then maybe I'll figure out what it means later. That's fine. But good grief, that's a lot of hassle to sort of like cram all that stuff in there and sort of hold on to it for no good reason and with no like real explanation. If you can really grasp what it means, then you don't have to memorize it anymore. Okay? Yes?
So to answer his question clearly, you need to say the thing, or how marginal cost and average total cost are related.
Yes.
Then we also need to explain why the marginal cost is shaped that way.
That's right. So it's a two-part answer. It's one, why is marginal cost shaped the way that it's shaped? And it's two, why does marginal cost cause average variable to do what it does? Yes?
Okay, I'm going to read you what I have. It says, as there are increasing marginal returns, the slope of ATC and ABC flatten. After the decreasing marginal returns begins, the marginal cost curve will increase. When they intersect or are the same, they being ATC and ABC, their slopes will begin to increase because if the cost of one more is greater than the average will rise.
Lovely. Lovely.
Can you go over that like you telling it, not?
I've done that like 16 times, but I'll try it one more time.
Okay.
Listen to the phone and talking to it.
But I'm starring in a YouTube video.
Oh, well then, you stay right there, that's good.
No, it doesn't matter. All right. I know, right? It's like the fifth time.
I don't know. I'm sorry.
No, it's good. It's good. It's honestly, it's like some kind of a, it's like some kind of like a mental exercise, and it's good. It's good for me. All right. So the cost of an additional one has to be a variable cost, right?
Yes.
Because the fixed cost doesn't change. We make 0 units, you got your fixed cost, right? Good. So then the cost of an additional one starts to fall because we experience increasing returns at first. Yes? So the increasing returns at first, okay, are the result of my fixed input being utilized to its capacity, right? I add variable inputs, and each of those variable inputs become more effective because they fill out my fixed input, right? And then my fixed input begins to be limited in its capacity, which means my variable inputs become less effective. I experience diminishing marginal returns. Yes?
Yes.
That explains the marginal cost curve shape. Yes?
Yeah.
Now, the marginal cost is the cost of an additional one. Yes? Well, if we start right here, the marginal cost for 1 is the same as the average variable cost for 1. Because the only cost associated with making 1 unit is variable costs. Because the fixed costs are associated with making 0 units. Right? So the only cost for making 1 unit is variable costs. Okay? As we move from 0 to 1, the only costs that are associated with that is variable costs, right? So the cost of making 1 more is the same as the variable cost divided by the 1 unit, right?
Yeah.
As I make a second unit, my cost for that second unit is lower. And thus the average variable cost falls. Good? And that continues. As long as my marginal cost, the cost of an extra one, is lower than the average variable cost, then the average variable cost will fall.
But as soon as it hits that point, then it starts to rise.
It's got to, because math works. And so Tristan
If I
comes...
had gotten to this point like 3 weeks ago,
Right?
I would be doing so much.
Right? But the good news is you got it today. Fantastic. Yes, Mason.
Can you go over the shutdown thing?
Yeah. These cost curves. These cost curves, right? These cost curves, right?
Right. Yeah.
Okay. These cost curves work for a perfectly competitive firm. They work for a monopoly. They work for an oligopoly. They work for a monopolistic competition. Those cost curves don't change. The only thing that makes a firm perfectly competitive, the only thing that makes a firm's graph perfectly competitive, that shows us that, is the key, the signal, is the
Price line.
The demand curve is horizontal. The price is horizontal. Okay? The marginal revenue, the average revenue, the demand, the price. They're all horizontal. Now you're asking about shutdown, right?
Yeah.
So if we're in shutdown mode, if we're in a shutdown situation, then we must be losing our fixed cost plus some of our variable. So where does my price hit this graph?
So this is the artery thing, right?
Somewhere below ABC. So yes, I'll use the purple to signify oxygen-rich blood being lost from the body. Critical damage. Okay? Price equals demand equals average revenue equals marginal revenue.
Oh, your
Sad face.
revenue is less than your cost. Okay.
Price sad face.
And I'm going to produce this many, right? Because marginal revenue equals marginal cost. To produce more means my cost is greater than my revenue generated. That's not a smart move. To produce less is to give up revenue I can have compared to cost. Got to go here. But by going here, look what happens. Oops.
That's all lost.
My average total cost is here. My average variable cost is here, which means this whole rectangle right here, what is that? That's my fixed costs. Those are my fixed costs. I could lose that money by not showing up. But I lost all this money plus this. Wow.
And that's when
Bad
you
move.
shut down.
And that's how you know that you don't need to go to work because you're losing more than your fixed cost.
If you lose more than your fixed costs, you can stay home and lose your fixed costs.
And that's when you need to shut down.
That's when you need to shut down and go home. Jerry Springer and bonds looks a whole lot better
Wait,
than losing $600 rather than just your fixed cost of $500.
so it's when your fixed costs are less than your total costs?
When your fixed costs are less than your total losses, you shut down.
And when
Yeah.
ATC is above normal profit or normal price, then you're
Well, in this case, ATC is above price, right?
right. Yeah.
But what you're asking is, if price lies between average variable and average total,
And that's just a credit.
I'm just going to lose. That's my loss minimization situation.
Okay.
Okay? Now, in that case, you're not bleeding oxygen-rich, like, pulmonary blood. You're just, you just got nicked. Okay?
You gotta cut.
It stinks for you.
Oh, fixed costs is less than total.
So it's like a paper cut.
Well, it might be worse than that, depending on how much you're losing. But it's bad. Okay, but it's not as bad as it could be. Okay? This is the ambulance goes really, really fast. Okay? This is the ambulance is there. Okay? So,
And when ATC intersects average price and you're at normal profit.
normal profits.
Now,
So there
on the-
you're still losing.
Now, when we're looking at graphs,
Yeah.
will you have like a specific point that we have to analyze, or just these lines and then the ATC and ABC?
Or is it more questions where we have to draw the graph?
Right.
You're just
yeah.
flinging the test around.
Ah! Well, let's consult the review sheet for a moment, shall we? I'll move your phone there, Tristan.
Oh, that's
Identify
fine.
them.
All right. Let's consult the review sheet, shall we?
I can't even handle how much more sense it's just
I'll read from the top left of the review sheet. You must be able to draw the market and firm graphs for perfectly competitive firms in all three positions: profit maximization, loss minimization, shutdown, and show how these markets transition to long-run equilibrium.
How does that
Which means you got to show loss, shutdown, profit, and long run.
Okay,
The ability to do this will make it possible for you to answer most of the questions on this test.
That's page 162.
Isn't it really in the textbook?
Most of it
Yeah.
is drawing.
No, it's in here.
And the workbook. Okay.
So wait, why does the supply curve shorten though after shutdown? Like what happens there?
The graph is drawing graphs.
Let's extend this. All right. Yeah. Let's extend it.
That's the long
So
run
wait,
though, right?
one,
The
that
industry.
is your loss is not greater than your fixed cost.
Yes. This is a loss minimization because my loss is smaller than my fixed cost.
Industry is long run, right?
No.
What?
Industry is industry.
Wait, what do you mean by long run then?
I mean, what do I mean by long run? Go.
Okay, so long run is however long your fixed costs stay fixed. No, that's short run, right?
No,
That's
industry
whenever
is
you don't
basically
make fixed costs.
Yeah,
part
your
of
fixed
part
costs
of the long run.
right.
In theory, it doesn't exist.
No, your long run is when everything becomes variable cost.
No, long run is when your fixed cost changes.
I thought you
Or
just said you didn't know.
All right. Let's deal with the shutdown situation first. Okay? That's an industry situation, yes? Yes?
Yes.
Now, Mason asked about the supply curve. Well, the supply curve is wrong on this industry graph. Why is the supply curve wrong on that industry graph?
Because it doesn't stop at price.
No.
Well, the
equilibrium.
supply curve is the marginal cost curve. So
What?
the supply curve.
The firm's supply curve is the marginal cost curve.
So
Wait, how do you find out where it is
Above
again?
ABC.
Say it again.
Above ABC.
Above ABC. So I'm going to throw my little green marker up here, and I'm going to say that's my supply curve right there. That's my supply curve,
So it usually just falls.
right? Now, why is only that portion of it the supply curve? Because if price drops below that point, will I produce?
No, you shut down.
No,
See?
go home and lose just the fixed, right? So that's where my supply curve stops.
Why is the demand curve on that one like blah, blah, and the other one is like straight?
Well, this is the demand curve for a product. And there's three reasons why the demand curve for a product is downward sloping.
Oh, yeah.
Income effect, substitution effect, principal, diminishing marginal utility, right?
Yeah.
So, there's your demand curve. But here's your demand curve for the firm.
Yay.
Because if you price higher, nobody buys it. If you price lower, you gave up revenue.
So an industry is like, what's the difference between a firm and an industry?
A firm is part of an industry. And in the case of our perfectly competitive
There's lots of
industry,
firms.
there's a whole bunch of firms who have all the same costs.
They're perfectly
So does your
competitive.
demand curve even intersect your supply curve on this side? Right now,
Say it again.
Does the demand curve even intersect the supply curve?
No, it doesn't. In fact, my supply curve stops right there.
That's all.
In the book, it shows it with a dotted line drawn down.
Yeah.
We can do that. We can do that.
That's indicating that it doesn't.
Where it would be, but it's not because I don't make enough money. I can't provide you that product at that price. It is costly for me to do so. Okay? Now, hang on, let me finish this one. If I did this, okay, what I'm suggesting is something must have happened. Either the supply curve shifted left and pushed the price up, or the demand curve shifted right and pushed the price up. Let's just say it's demand. People decide they really like greebies, okay?
How do we know which one it is on the test?
In this case, you don't. On the test, I'd give you some indicator, okay? Maybe a tax, boom. Or maybe people decide they really like this product, boom. Or maybe the price of a substitute rises, boom, right? So, in any of those cases, either my demand curve increases and pushes the price up, and now I'm just losing money. Okay? I'm not bleeding oxygen-rich blood. I'm bleeding regular blood. I can hold out for a little while. Okay?
Ambulance is on the way.
Probably not going to need